So this is a group of Bangxi, Yuyang, and Yue. And this is our main Git repository where you can find the deployed website on Amazon AWS, and here is a short link. Let's look at the About page followed by the data acquisition, model, DB, and the web application will come to the end. So this is a web application on displaying and visualizing trending movies, which is our main page, and then there's a search page to train online machine learning models to predict the score of a user written review. Alright, the possible next steps includes using a deep learning model instead of a machine learning model. And the web scraping process and model training takes a long time when user input a movie title. So maybe we can also improve on the time of those algorithms. References includes IMDb, which is used as a data resource, and Plotly, which is used basically to create this website. And here are also some related work with a similar topic. Alright, Bangxi will start to introduce you with a more detailed structure with this web application.
Well, hey guys, I'm Bangxi Xiao, and I'm going to introduce you the whole structure of prediction project and the work I have done. So this is a structure map of our project. As you can see, we use AWS Cloud9 platform as our primary service and MongoDB as our database system. And here are two forever running services. The first is data acquisition, which is to routinely acquire data from imdb.com. And the app.py is used to keep the website running. And our mainly developed website have two major functions. The first is to respond to the data we acquire from data acquisition progress, which is we have data visualizations and the movie information. And also we developed a user interaction system for users to search for a movie and give their own reviews to the movie, and we will produce a predicted score according to their review through our NLP models. Well, here's the searching progress of the movie. If we search movie Dunkirk and we click search, and it will return some movie information and the visualization we have done. And also, if I entered a relatively negative review and I click predict button, and it will return a score predicted by our predicted model. And here's the main page of our movie website, where here are a lot of interactions. Yes. Then I will introduce you specifically the AWS Cloud9 platform, which is our service. As you can see, we have entered our IDE. And the first function we are introduced is the data acquisition. The web core implements the web core function is used to acquire data from imdb.com according to our website functions. And the preprocessing.py is some functionable functions which help us process the text and some other things. And language process implements transform a document to maps a document to its corresponding vector space, which is used to which we use the resulting vectors to train the model. The main model we use is doc2vector model, and you can see we have attached our reference paper at this project. And also the database, and also the application.py implements the website. Well, now I'm going to introduce you the Amazon ECS, which we use to monitor our services. As you can see, we have now one service running, and you can click in to see their status, and you can see it's active and it's correctly running. And also I'm going to introduce you the Amazon Lambda function, which we use to routinely update our database. You can implement a Lambda function inside there, and set a time to run them. For now, we set the Lambda function is run every 7 days to update our movie database. Then I'm going to introduce you our code pipeline, which is used to maintain and upgrade our applications. So if you made some alterations to the code there, as you can see, I have just made some alterations to app.py and database, and you just need all you have to do is to use Git to push your upgraded codes to Amazon pipeline, and it can automatically source and build and then deploy to your website. It's very convenient. And that's the whole work I have done. Thanks.
Hello everyone. I'm gonna present the part of the data, the main part of our final project for data 1050 classes final presentation. I'm going to go through the database design part of our project. As you can see, this is the schema of our database. It has several columns. The ID, which is in serial data type, is our primary key, followed by the column including movie ID, title, year, content rating, length, genre, score, metascore, book numbers, gross, director, actors, and genre overall. And then each one has its corresponding data type. As we move to our database on the cloud, which is we use MongoDB on the Atlas, here is the cluster. And then once I show the collection, as you can see, the database, our database name is movies. We have our collection pop movies here. And then currently there are this amount of total documentation. It includes the first 2 weeks of our data sets. They are already in our database. And then we update our database per week. So for example, you can see over here, this is an example. It has the ID, movie ID, title, until genre overview. So those are all the data we have in our MongoDB Atlas. And then those are the code part that we use by the MongoDB. And then so we use PyMongo, and then we connect that through PyMongo to the connection URL. And then the observe movie function is to upgrade and insert our movie weekly, and then we can get our movie by running the fetch function, and then we can also fetch them as a data frame. What's more, before we actually upload our movie, we have to transform the PKL to the data frame, because the input of the function is the data frame in this case. And then another function is the DB update function, where we can running this to update and insert our movie and then fetch the movie. So that's pretty much our backend database design schema for our final product. And thank you. That's it.
Alright, here's Yue, and let's talk about the dash app part, which incorporates all of the DBPs, like imports data frame from the database, and also the model piece. Right, so this is basically the app.py. I'm just running it on Jupyter Notebook. Alright, so here is the website. Basically, the first part of this main page have a roll number versus score, and it has a drop-down menu of different years. But overall, we can see like a positive correlation between roll numbers and scores, which is easy to understand, because like the higher the score is, there will be more people willing to pay the ticket to see the movie. So, but however, there are also movies with higher roll numbers but low score, like 50 Shades of Grey, and also movie with a high score but lower roll numbers. And the scatter size is determined by the graphs, and the color is determined by genre. Okay. Then the second piece in this main page, I'll go very quickly first. is this data table, which can be used to delete data and also delete columns if we would like to. This is basically everything from the database, but there's something we can do. So other than deleting rows or columns, we can also filter data. Like if we want to see only movies from, let's say, after 2017, then we can just do a filter on greater than 2017. Oops. And then it will only return movies about movies after 2017. And we can see that page number is reduced to 79. And if we want to see director name Nolan, we can just type here. Okay. And then we can see all of Nolan movies are returned. And then the third part of this main page is the different genres, and it's about the length and the score with different genres. Animation is the shortest. Okay, that's basically the main page. And on the top right, I have a header going to the About page, which introduces this project, the project details, and the links that we are required to include. All right, here on the bottom, I have back to home or go to search. So go to search is the feature we have on model. That's basically the link of enhancement as well. All right, so let's go back to home first. From the home page, this click here also gets us to the search page. All right, search for a movie. I did Dark Knight before, so let's do like 2012. It needs some minutes to scrape from the IMDb, so it will take about like 2 minutes. But here's a loading feature, and it will disappear after the movie is loaded and the train model is loaded. And we can also see the progress right here. Alright, it's finished. Alright, so after loading, it returns the movie title, which is 2012, and also the movie released year, which is 2009. Then also a table that has the movie details, like the title, the actors, the storyline, and there's a workout from the reviews which will not be on our website because AWS have some issue with that bytes.io part, which I used to encode and decode the image returned by the workout. And as you can see, I commented this part out in the app.py. But other than that, there is also a graph on the score trend over time. So basically, we scraped the data, extracted the scores in all of the reviews, and then averaged them over time. So here's the score trend, and all of the red dots are the individual scores. Like one day on 2010, there are people voting like 2 for this movie, 8 for this movie, all over the place. Alright, but our feature is this train model. And I did this recording once, but I'm just such a slow typer right now, so I'll just copy and paste. But I did not hit the predict last time, so be a fair game. I don't really remember this movie because it's so long ago, but I just said I love this actor, but the director ruined it, so don't waste your money on this. Okay, so I'll say like 5 or 6 because I still will have some scores for that actor I love. And the predict score is 6.53, which is higher than what I'm thinking, but it's still there. Alright, this is just the search page, and then I have a link to go home, but that's about it. That's our app on the movie data.